Hello, my favorite CopperCube people. Recently on the forum, I have seen a lot of questions about how to organize enemy AI, how to implement melee AI, and I mean, overall, quite a lot of questions related to some general stuff about enemies' artificial intelligence. And in this code alert video, I would like to share with you the approach which I am recently using and which I think is sort of really good and pretty clear and gives you quite a lot of control over the enemy behavior. It's also sort of extendable, so you can use it for other type of behaviors, for example, for camera controllers, for animation controllers, for stuff like that. So let's talk about the approach first. The thing which I'm going to be using is called state machine. The idea is that you have different states. So if you're talking about AI, let's say it will be like idle, run, maybe I don't know, like attack or something like that. And depending on which state is currently active, on animate function will behave differently. So it will execute under it will execute different methods of your behavior class. So, for example, if I'm currently in idle state, if my node or behavior or like game entity currently is in idle state, it will execute, let's say, function idle, something like that. If it's like in run state, it will execute function run. So that's the basic idea. Overall, current implementation also allows you to execute sort of additional functions. So then when you're changing state, for example, if you're in idle state and you changing it to run, it will also execute additional functions on exit from idle state and on enter to run state. And these two functions, they will be executed only once. That's the general idea, and I have the whole state machine already implemented. I won't do the code alone of this part. I've stolen it from another YouTube tutorial, and I will just leave the link in the description. So if you want more details on how the whole thing is implemented and how it's working under the hood, you can just check it there. And in this video, I will only focus on CopperCube part on how you can exactly apply it to CopperCube behavior. So first of all, let's talk about implementation, a bit what we have here. And this is your basic state machine class. It has an object which contains the list of states. It has a property for current states. These are used for internal things. Once again, you can watch the video from where I stole it. And regarding methods, you have your add state method, which allows you to specify methods for your entity. So let's say we can add like idle state, run state, walk state, and stuff like that. And you have set state method, which allows you to set current state. So for example, if you're currently in like run state, if set state, you can change it to, let's say, walk or attack or whatever. And also there is update function, update method, which we need to put inside our own animate function, which will be called every frame. And this update state will allow us to execute the correct function based on current active state. These two are just helpers. This is a bind function, which allows you to bind any function to your object. That's pretty, like, I think it's not clear from the description, but if you want, once again, if you want to learn more about context, about binding functions, you can sort of ask ChatGPT, or you can just Google it. It requires a lot of theory on how prototypes works, on how context works in JavaScript. So we just leave it. Will focus on practical stuff. And another one is object create. This allows you to create a new object from a prototype of a given type. Not given type, from like a given object prototype, basically. This one, all of this I will put into a dummy action, which does nothing. I will edit before first row, so we can use the whole state machine object in our behaviors, and that way it won't take any additional space in the actual behaviors. So it will allow us to have a little bit more clear code that way. So if it's not clear right now, it will be much clearer as we go through the whole coding part. And I mean, just stick with me. It will be fine. I promise you. So first of all, let's start with CopperCube part. Let's set up our scene as usual. Remove default cube. Let's add a plane. It will be like 300 something, so it's big enough for us to test. Put it on 0 coordinate. Let's save our file here. So it will be zombie test save. I've already prepared a model which I downloaded for free from OpenGameArt, and I've added some animations using Mixamo. It's sort of large, as you can see. I'm not sure how to make it smaller in Blender. Like applying transforms and stuff like that doesn't seem to work for me, and to be honest, I don't care. It's fine that way. And let's just scale it down a bit. What I know that this is that values which I need to use to make it more or less like okay height. But also what I like to do is I like to put these default guys from prefabs and put them in the same position and sort of like compare the height, so my models look sort of like this, so they are sort of the same height, sort of the same proportions. And we need to add the texture. Let's apply it to our material. And we also need to rename animations because currently they have these like armature prefixes. Also not sure how to remove them in Blender, and I'm just doing this here. Armature, armature, scream, T-pose, and the very last one is working. And yeah, everything is renamed, so our model, I believe, is prepared. And also the thing that you need to be aware that your model should always point the same direction as the default prefabs. In that case, all the default built-in into CopperCube behaviors, actions, and stuff like that will work with no issues. And this is something that I'm also used to keep everything sort of, how is it called? I forgot the word. So everything is the same. Consistent. The word is consistent. Let's remove the default model and push this guy somewhere here, and let's change animation to T-pose and add our character controller. It will be default first-person camera. Let's put it in 0, coordinate. Let's put this thing somewhere here, so we're looking at the zombie from the beginning. Oh, I also see that it's sort of looking a bit sideways, but I mean, I don't think it matters. And let's test the map. So as you can see, the model appears properly. So at this point, everything seems to be fine. I also don't like the ground. I will change the texture to something else because it's the same color as the model. And also, like, let's just discuss what we are going to be doing. First of all, as we start game, our enemy will be in idle mode, in idle state. It will does nothing, just standing there. If you get close enough, it will activate an enemy. It will go to a scream state where it will face player and scream at the player. And after that, it starts following player with walk animation. If it gets close enough, it will do an attack. And also, if you shoot to your enemy multiple times, the zombie will die, and then the model will disappear from the game. That's basically what our goal is, and at this point, we only just need to do some renaming, and we need to do some other scene configuration. First of all, let's add required behaviors to our enemy. The first one is collide and move. We need to set, I think it will be like minus 11, 11. No, 11 is too high. 10. Okay, I'm not here for precision. It sort of works. I think it will do because, I mean, not that many objects to hit here on the level, not that many obstacles. And the other thing which we are gonna be adding, we will add game actor with health, which is also default behavior, and we will say that this is a player, and we will remove all the animations here because we don't need them. Not now. How do I remove it completely? Is there a way? Okay, I think it doesn't matter, to be honest. I think it will work that way, I hope. Or we can just adjust it later. The idea is that it shouldn't play any animations. It's just we will be controlling animation from our behavior. And at this point, I think, okay, we can also just put, not okay yet. We can just put another game actor behavior to our player. So this is also, so the player also could be hit and could sort of die and stuff like that. So the scene is pretty much configured at this point, and we can proceed with coding. Just navigate to your extensions folder and open the extension or open the file with your um, IDE or with your text editor of choice. I'm using Visual Studio Code as usual. I also have templates for actions and behaviors, and what I'm doing, I'm just copying the template and start developing using the copy of template. If you need more details on this, I have another Codalone, another JavaScript tutorial, and in the very last video of it, you can see how to create behaviors, and you can check it, and basically it will make sense. Let's call it zombie AI, something like that. Rename a template everywhere to our zombie AI. It's important that JS name correspond to the file name, and also object name should also be the same as file name. Let's save it. Let's remove all properties and then go back to our scene, go to edit, plugins, reload and verify extensions. I hope everything is fine. I believe it's fine, so we can pick our zombie once again and that another scripted behavior, which is called template behavior, because I didn't I didn't rename it here. Sorry. Just call it once again zombie test and then AI. And we will go to edit plugins, reload everything once again. It's fine. Go to scripted behaviors, and now we have our zombie test AI. Currently it does nothing, but it's a good idea to just check that it loads and it doesn't give us any errors, which it doesn't, which is pretty great at this point. So the very next thing which we need to do is we need to somehow make somehow make our state machine functions to be available inside our zombie AI. And what we're going to be using is called inheritance. Basically, it's inheritance. Inheritance in JavaScript pre-version ES6 is pretty weird, and I will also leave a link on how inheritance work in the description to this video. And now I'm just sort of stick with me. I will just copy copy the code without any explanation. So first of all, we will have our object prototype, and it's in correct place because it's important to keep it in the right order here. And we will just create a new object from our state machine prototype, and we will say that our behavior zombie A prototype is equals to this object. And the very next thing which we need to do, we need to redefine constructor, and this constructor will be just our behavior zombie A constructor. And here inside the our class declaration, we also need to execute state machine call this. So that way, basically what we've done, we inherited our behavior zombie AI class from state machine class, and now we are able to use all the methods which are mentioned here, like add state, set state, and stuff like that, um, inside our behavior. And let's just run the application once again and see if it actually says that state machine is undefined. Yes, sure, because I forgot to put it in the game. So we just need to go before first droning. And here we will need to add an action, which is called reset action. It's this one. So it's zombie test reset action, one which I've pre-created. Let's run it once again, and we see that there are no errors, which means we are good to go. So first of all, first things first, let's start with defining our states. We will have a couple of different states which we need to implement the enemy behavior we were talking before. And I just like to define all such states as constants. So we'll have like idle state, idle, yeah, so it will be zombie, not zombie, let's just call it state idle. Then we will have a couple more, which will be, I think it will be 5 in total. So we will have like follow. So in this state, our zombie will follow our player. We will have state scream, in which it will just scream at player and face our player. We will have state attack. Then our zombie will attack our player, and we will have state death, which means that our zombie is completely dead and should be removed from the game. So as this is done, the next thing which we need to do, we need to define this all these states using our add state method. So we will be calling this add state, and let's do it one by one. So the first one will be zombie state idle. Second argument of this function, I will just remove it for now, colons for now, because we will add our states. And okay, so the second argument will be an object which allows us to define multiple functions which we can use. We can specify on inter, on update, and also on exit functions here. In our idle state, we don't really need on exit because there's nothing that we can put there. But overall logic would be that then our enemy, our zombie, enters idle state, the only things that we really need to do is we just need to switch animation. So the animation should be set to idle animation. Anyway, for this, I will just add another method here, which will be called idle on inter. And for this one, I will add another method called idle on update. And now we just need to write these methods. We don't really need on key event here, so let's just say on inter idle on inter. Oh my god, idle on inter is function. We will pass one argument there, which is node, and we will say that we need to set scene node property for this node animation to be, I believe it's called idle. Let's just double check. So we have, yes, we have an idle animation here. And we will need another function for update. This will be idle on update. And currently we won't do anything. We just need to make sure that everything works. And I've taken these names like on inter, on update from here. So as you can see, we have like states on inter, state on update, and also we have state on exit, which I believe we won't be using in this video at all. So currently we almost have anything we need, except we also need to call this update function inside on animate. And we will pass our node and also delta time to it. And also let's just add this second argument here, so we don't forget about it later. And now if we enter our game, we see that nothing is happening. That's because we didn't, even though we added the state, we didn't set the state. And in order to do so, let's just go here. It's our first run of our function, so it's only executed once on a very first time, then we don't have last time set. So let's just do this set state, and we will set state to zombie state idle and pass node argument there. Let's check it once again. Now, as you can see, our zombie 0 changed state to state idle. So now it stays and it does nothing because basically there is nothing inside on update function yet. The very next thing which we need to do is we need to change state to scream if player is close enough to our enemy. First of all, we need to calculate distance to the player, which is pretty easy thing to do in CopperCube. We just need to get position of our zombie node by getting scene node property node position, and we need player position. In order to get player position, what I also like to do, I like to add a player node as a property to our class. So we just ccb get scene node from name, and the player name is player. We just put it here as an argument. And we will get player position here the same way, and it will be like this player position, player node, I mean. Now we, in order to calculate distance, we just subtract player position from our node position and call get length. And if distance is, let's say, less than, I'm not sure how much, 30, we will just print for now, for debug purposes, that player is close enough. And let's check if it works. Yeah, so it's like really close. We need to do it a bit like far. This activation trigger should be a bit far. So let's just print the distance and see what the distance is. So let's say it's closer than 50, I think, for the testing purposes. It's fine. You can always fine tune it later than you're working on balance of your game and stuff like that. So at this point, we need to switch to another state. And in order to switch to another state, we need to add it first. Let's add another state, which is called zombie state scream. We need another two functions, scream on inter and scream on update. Yeah, seems like it's spelled pretty much properly. And let's just copy this one, rename it to scream on inter, and remove. Oh, we don't need remove to remove it. Basically, we also need this animation to be here. Scream on inter. Okay, on inter. It's not named properly. Scream on inter, scream on update, and we also pass delta time here. Now inside scream on inter function, we need to change animation to scream, and it's called scream. I love how logical it appears to be. And here in our idle on update, in our condition, if distance to player closer than 50, we can just set state, our active state, to zombie state scream and pass notice second argument and see if it works. So currently, if we got close enough, our enemy should change its animation to scream, which it does. And also you can see inside the debug console that our zombie changed state to state scream. So scream state should switch to follow state after some time has passed. How to calculate, like how much time does it actually take? Basically, you can pick any time, but usually I am setting such state based on animation length. So here we'll have that many I mean, it ends at this frame and starts with this frame. So you calculate length of animation by just subtracting one from another, and then you need to divide it by FPS, since it's FBX and it's imported from Exama. It's pretty weird value, and we will get something like 2 seconds, 2.77 seconds, which is like 270 milliseconds. And here on Scream on update, we will introduce, or not in this one, in Scream on inter, we will introduce another property which will be called Scream state length. Probably not the best name, but I mean, whatever. And we will make it equal to our animation length. And I will also edit this property here just for consistency. And now every time we call in scream on update, we will have a delta time. I'm gonna subtract delta time from our default scream length. So let's say we have like a frame 0, and when it changed to frame 1 with 60 fps, it will be around 60 milliseconds. So it will be like 2070 minus 60, then from another 16, and so on until it reaches 0. If it reaches 0 or less, we need to make sure it's still either 0 or less. So we just do math max y. Okay, it will be either 0 or current scream length. And if our scream length is 0, in that case, we're gonna change our state to the next state, which is follow. And once again, we need to add an implementation for this state. So let's say zombie state follow, and we will have follow on inter and follow on update. That's it. Let's create functions for that. Once again, we need on inter function in order to change animation. So this time we will be changing to walk, I think. Let's see. Yeah, it's called walk. And in our update function, node delta, we will make our enemy follow our player. So how do we do that? First of all, same as it's oh, okay. Yeah, okay. I forgot about one thing. So basically, this all good, but we have this behavior. It doesn't act like I want it to act. So currently, as you can see, no matter like which way you are, like where you stand, it doesn't turn. So your enemy doesn't rotate the way your way. And let's just fix it really quick. First of all, we need, as usual, like if you're talking about some stuff like space and rotations, the best thing that you can do, you can just use trigonometry, or you can reduce everything to Pythagoras and Pythagoras, and that's what we're gonna be doing. So we need to get not rotation. Let's just think about it. So first of all, we need to get positions once again, as it was here. Then the next thing, we need to understand what is an angle between this position and that position. And in order to do so, we can use eight arctangents of of I'm not be like drawing the diagram. I think I'm just gonna guess. I think it will be like that. But once again, it's pretty much just trigonometry, and this will be our angle. And let's just do it let. And in order to make our angle, so this function, this static method of math class will return you angle in radians, and we need to change it to degrees, to 80 degrees. So we'll need to multiply it by 180 and also divide by pi. And now let's just apply our rotation. We only need rotation on y-axis. Basically, I don't think our zombie will ever rotate in any hour, so we just set our axis rotations to 0. Set C node property node, and then we'll do rotation and set it to 0 for x-axis, angle for y-axis, and 0 for z-axis, and see if it works. So wrong amount of parameters. Why is it so? Node angle. Set because I just wrote get instead of set. So now, as you can see, it turns it turns the other way. It turns it's back on us. Basically, I didn't guess it. It needs to be player x minus pose x, and also player z minus pose z. This is something that if you sometimes it's faster to try than to try to figure out how it should work. So now our zombie looks our way, and also it starts moving. So all this calculation, we also need to make in our follow on update method, and in order for our zombie to always look to the player, so it should be like faced correctly. So I'm gonna move all of this to another method, and I will call it like behavior zombie AI prototype, and then get something like get player player face angle. I don't know. Let's say it like that. I'm sort of struggling with naming it properly. And we need to pass our node here, and so now we can just let's I'm not sure if we need to return it in radians or in Euler, but let's just return it in radians because we will need to use it later to uh, calculate change of position when we will make our zombie move. So it has node, it has player node, it returns everything, and so now here we can just say that angle is this get player face angle, pass node there, and here we will just multiply it by 180 and divided by pi, and we will do this, we can just make it const, and we will need to do the same for player on update. And since now it's moving, it's following player, so it should move, we also need to calculate a new position for our zombie. First of all, let's just specify the speed with which our zombie will move, and I think it will be something like 0.01, something like that. No, it will be too slow, 0.1. Let's see. And this is pretty much the same as I was doing in create your first behavior tutorial. So we can just, so what we need to do, we need to calculate distance on which our zombie moves on x-axis and also on z-axis. In order to do so, we will take a sinus of our angle multiplied by delta. Since it's some sort of a change, we need to also include delta in order to make sure we are not affected, this change is not affected by the FPS. And we will also multiply it by speed, and we will do pretty much the same for what can I no okay, so we have dz and we will use cosinus here, and that will be it. Now we just need to take a position of our zombie, current position, see node property, node position, yes. And we will need to set a new position, node properties, node position, where our position x will be incremented by dx, our position y will be the same, and our position z will be incremented by dz. And we will have set properties, and let's see if it works or not. So now it will scream at us, and now it should start. Oh, too fast. Okay, all right, I got it. It's too fast. And if we just set it to 0.01, scream faster. So now it's sort of moves, but it's still a little bit fast for animation like that. Let's say it's like something like that, maybe. I think when I was testing it, it was this value actually, and now I can remember. It fits. His feet still slip a bit, but I mean overall it looks more or less okay. So now it will always follow no matter what. And now we just need another condition. So if the zombie is close enough to you, it should stop and attack. In order to do so, as usual, we just add another state, which is called zombie state attack. We will create two more functions, attack on inter and attack on update. And let's just code them really quick. So let's copy this one, so it's faster. And let's say attack on inter, on inter. And we will switch our animation to attack. I believe it's called so, yes. And the same as with scream state, this is sort of one, it's not looping state like walking, it's just one shot. So it shoots and then it resets to idle state, and then it's qualify, when it's sort of try to figure out what to do next. For that reason, we also need to introduce another variable, another time variable like that one, but it will be for attack state. So it will be attack state length, and we also need to figure out how long will it take. Let's put it here for consistency as a class property, and let's figure out how long does attack state takes. So it will be divided by FPS, and it will be around 4600 milliseconds, something like that. And we will pretty much do the same logic as with our scream on update state, but in our attack on update state, and we need to replace scream state length with our attack length, and in case attack has ended, we need to switch our position to our state to idle. So it's pretty much the same logic as with scream right now. Let's see how it works. So now let's just get close enough. It starts moving and nothing will happen. Yeah, because I've obviously forgot to introduce the condition how it enters into the attack state. And in order to do so, we need to update this follow on update function. So once again, we need to calculate distance. So how do we do it here? Player position. Let's just copy it, but basically you can just make another method and edit everything there, so it's sort of clearer code. But anyway, if let's say distance is less than 20, in this case we will set our state to zombie state attack and pass node as a second variable. And now let's see if it works or not. So it's in idle state, it's in scream state. Now it gets closer, and now it starts attacking. And if you are far enough after its attack, it just changes its state to idle. If we repeat this process once again, as you can see, it will also work and can also attack once again. If we close enough, it just changes to scream once again. Probably this is also something that we can fix so it doesn't scream, but I mean, you can figure it out yourself if you're interested. Yeah, where we are. The next thing, even though it attacks, currently it doesn't do any damage, it just plays the animation. And there are a couple of ways how you can implement damage. First of all, and the most obvious thing, you can just add where is it? Not attack animation, action on attack, in order for your zombie to shoot player with short distance and I mean, and then just call this AI command like node attack player node or this player node. But I will just do a simple distance check, not distance check. I will just do a simple like calculation here and reduce the amount of health manually, just for just for a change. So if player is getting attacked, we are gonna reduce player health by some sort of value, let's say by 10. And we need to implement this function, this method. let's say behavior reduce player health by equals function some value. Um, First of all, we need to know, basically, first of all, we need to get player name. Then there are these special variables which you can change to update health value. We need to calculate this variable for a player, and then we need to reduce values of this variable by the value specified as function argument, and then set it back. So sorry, just set the updated variable back. So basically we do get CopperCube node property our player node, we will get its name, and then our health variable will be hash plus name plus health, and then we're gonna get this value, so it will be get CopperCube variable health var. We will subtract value on which so the damage value here, it will be like new health value, and then we need to set it back. Set CopperCube variable new health value, not new health value, health variable to new health value. I think it should work. And so now it's reduced by 10, and in order to make sure it works, we just go to player, and when we have this game actor, and uh, there is action on hit. So inside an action on hit, we will add a simple JavaScript which will tell us that player is hit. Something like player is hit, and yeah, like that. So now then our player is getting attacked. So you can see that player is hit, which basically means that player health is decreased by 10 every time zombie attacks. Currently, also one thing that you might notice that it attacks zombie damage is applied at the same time the animation starts here because we have it in this function. We can sort of shift it to a later time, and we also can add some additional checks. Let's say like in our distance check to make sure that the player didn't run away, didn't escape the attack, and we will be doing it by switching this thing here, and we will introduce another variable like is attack landed equals to false, and if let's say our our length which is already left is less than what should it be, 306, something like that. I'm not sure, like it also can be tweaked, and our is attack landed is false, so it's not landed yet. We will just reduce health inside this block. Once again, you can also, for example, like make another distance check and also say like if, for example, distance is greater than 25, not great, I mean less than 25. In this case, it will happen. So, if, for example, distance is higher than that, this means that player escaped and was not hit. You can also rotate your enemy towards the player in this function. So you can do a lot of stuff. I mean, but it's all tweaking, and we will not touch it. We're just talking about the general approach. And so now, oh my God, okay, it's hit, but I mean, we already died because I didn't change attacker's landing property to true here. So now it will only hit once. And also keep attention to it, like at which point the attack will be landed. So bams, and it's just perfect. So he just the damage is applied and at the point on animation there it should be. And also, for example, if you're adding some effects here, you can like add stuff here, for example, like blood splatters, or I don't know, or like attack sound, hit sound here, so you can just play, for example, sound here. That's also sort of useful because it will be only executed once and you don't need to think about like keeping different variables. In order to define, then it should be played. All right, all right. So we have more or less everything related to it. Let's just add for the change. Let's just add another condition. So let's say in this follow on update, then our zombie is following us. Let's say player just got too far and zombie doesn't follow us anymore. Let's just say the distance is now higher than 100. In this case, we will just set the state to zombie idle, and we will just add return here and here in order for function stop executing here. So um, if it changes, if zombie changes state to attack, there is no need to go further, even though it won't happen anyway because these two conditions contradict to each other. But let's see if it works. So now it screams, it should start following, and if you get too far, it just stays once again. Also, another thing which you can do to make it a little bit more random, you can add random. that's, that's, even though it sounds strange, but I mean. So let's say if distance to the player is less than, not this one, sorry. What? No, not this one. If distance to player is less than 50 on idle state, for example, let's say in 50% of cases we want zombie to scream, and our 50 we don't want, so we can just do it like math random. This is a static method which will give you any random value from 0 to 1. So if it's greater than 0.5, let's say, in this case we will call this state. Another case we will call state follow. So let's see if it works. So now, as you can see, it just started following us immediately, and it started to following us immediately, and it started following us immediately. Come on. What the hell, does it work? Screen follow. It should. Let's just try a couple more times. I think it. So now it screams, okay. And one more time. So it screams. So yeah, I mean, it's random, right? So it should scream for the first, and now it follows. So it's random. Half time it will follow, half time it will scream first. You can also apply this sort of randomization to any other state, transition. You can also, like, if you have some states which with let's say this one with a fixed amount of time, you can randomize amount of time which your entity spends in a state. So that way you can make it a little bit more interesting. So the very last thing which we need to do, which is left, is apply death. And this one is a little bit trickier. I'm going to be using CopperCube variable in order to achieve that. So for each enemy, we will have special variable which will say if enemy is dead or not. And it will be just, so how do we, okay, so let's say we will take our node name, get in node property node name, and then we will add is dead, make it sounds good, and let's just remove this all and set CopperCube variable. So we will say that we need a variable with name of our entity plus underscore is that, and it will be set to 0 by default. And inside our on animate function here, every frame before executing this update, we will be checking this variable, and if this variable is equals to 0, or we can just leave it like that. So if in this case we will set state of our zombie to zombie state death, and doesn't seem right. Okay, and also if what am I talking about, and I'm saying it doesn't seem right because this means that in case variable change its value to 1, or like to some other positive value or negative, or basically anything but 0, this means that this part of the code will be executed every frame, and we also need to check that the current state of what current state of where is it? Okay, current state of our zombie. I'm sorry, I just need to look up how it looks. So it's just current state. That current state is not already zombie state that. Yeah. So in this case, we only switch in the state in case it's not zombie state death already. So that's the case. Basically, once again, we just check in the variable. If variable is 1, in this case, we will, and also in case current state is not already zombie state dead, we will set this state to death. And we will need to add another state here, like that, and we will call it zombie state death, and we will say that this is death on enter, death on update, and we will introduce another variable here, so it will be death state length to be equals to 0, and we just need to implement these two really quick. Once again, it will be pretty much the same as with attack or with scream on enter. Let's put it here, so it will be death on enter. We will change animation to death. That's unexpected. I'm not sure how long is this animation. I'll just set it to 5 seconds. You got the idea how to calculate it, and probably you need a little bit more time on this because def state length sounds right, and we need to add another on update state, on update node def. It's all about death. And we're doing pretty much the same logic once again. So in case we decrease def state length of every frame, if it's 0, in this case, we're just gonna remove the entity from the game. So remove C node, is it called? Yes, and just remove, make the node remove itself. Yeah. Sounds about right, but there is only one thing which is left, is that we need to somehow set this variable, and in order to do so, we're gonna be using the built-in um, game actor behavior, and here we have action on die, so we will just write another action which happens on player death. So let's just copy this one. Oh no, we won't copy it. Let's just go to action template, copy action template, call it the zombie dice, rename it here, we name its description, I mean change its description, zombie dice, and we don't need any properties. And here we will just pretty much do the same logic as in behavior. So we will get the node name and we will add is that a postfix to it, and we will set the value to 1. I think this will do. So let's just go to our CopperCube editor, plugins, reload, and here under zombie game actor behavior on die, we will just put our special zombie dice action. And also on hit, since we will be hitting it with the ball, we will just add another execute JavaScript, and let's say print zombie is I don't care. Okay, zombie is hit. I don't care about spelling at this point. So yeah, and also like we need a way to attack, so let's just do it like the really quick and dirty way. Let's just add a sphere, which will be our bullet somewhere. Call it bullet. And then on the player object behavior, we will add another action. Oh, I mean behavior triggered by event when key pressed. If key pressed is left mouse button, and then we will do action special. No, games and sounds shoot using node. We will select our bullet here. Let's just set damage to something like 34. So you don't need to shoot that many times. And now we can shoot. Our zombie still works as expected. We can hit it, as you can see in the console. And if it's got hit, it sort of dies. And then it's removed from the game. Okay, I thought it would be longer, to be honest, but I believe we more or less got through the whole thing. So, to conclude, to make some sort of conclusion, this is a pretty straightforward, and I believe this is a pretty simple way to control your AI. Since you have separate stages, you have separate functions for everything. So you don't need to have like million different variables to control the flow. And it's sort of like seems to me like this is a really good approach, and this is something that you can use. Once again, I will put everything. Okay, you know what? Let's just try another zombie. I just wonder if it works with, let's say, two. What that would be like really interesting if it doesn't work with two zombies. So now this one is screaming, but I'm gonna shoot the second one. Yes, it dies, and this one is moving. This one attacks. Yeah, okay, so everything's working. That's perfect. So basically, this is something that you should try. I will leave all the links I've been talking about. So this is a tutorial explanation of inheritance, how inheritance work in JavaScript, and also files for this project in the description, links for all of that. And thank you for watching. If you have any questions, please address them here in the video or on CopperCube forum. See you next time.